wherever you are listening from tonight, whether the lights are already low or the world outside is still quietly busy, I'm glad you're here. This is a place for wondering without rushing and learning without needing to stay wide awake. Tonight, I want to invite you on a journey that begins very close to home and then keeps going, far past the places most of us picture when we think about space. Not a fast journey, and not a dramatic one, but a steady, patient drift outward, guided by a small machine that has been travelling for longer than many people listening have been alive. A machine that keeps whispering back to us even now from a place so distant that the word far starts to lose its meaning. Before we go any further, let me ask you something simple and personal. Where are you listening from right now? Are you curled up in bed, resting on a couch, or perhaps listening through headphones while the room around you slowly quiets down? And what time is it for you, in your part of the world at this exact moment? It's fitting to ask, because tonight's story is not just about space, but about time, distance, and how our minds struggle to hold both at once. If you find this gentle exploration calming, interesting, or simply a nice way to unwind, you're always welcome to like the video or subscribe. It helps this small pocket of quiet science reach others who might need it too. There's no rush and no pressure. Just know that you're welcome here. Now let's begin slowly. Imagine receiving a message from something that left Earth before many modern conveniences existed. Before smartphones, before the internet became part of daily life, before GPS quietly told us where we were without us ever thinking about satellites or signals. Imagine that message arriving not seconds or minutes after it was sent, but many hours later, crossing distances so vast that even light itself needs most of a day to make the trip. And imagine that message still coming, steady and patient, from a place where the sun is no longer the bright ruler of the sky, but just one star among countless others. This is not science fiction. This is happening right now. Far beyond the orbit of the outer planets, beyond the neat diagrams most of us saw in school, a spacecraft continues to move outward, carrying instruments, data, and a faint heartbeat of radio signals back toward Earth. Those signals do not shout, they whisper, and yet, in those whispers, they tell us something deeply unsettling and strangely comforting at the same time. They tell us that the solar system is far larger, emptier, and more extended than our intuition ever prepared us for. When most people picture the solar system, the image that comes to mind is often compact and tidy. This sun in the centre, a few planets arranged around it like ornaments on invisible rings, and perhaps a vague sense that space ends not too far beyond the last planet. Even when we know, intellectually, that this picture isn't accurate, it's hard to let go of it. Our brains like manageable scales. They prefer distances that can be compared to road trips, flights, or at most, the size of a country or an ocean. But space does not care what our brains prefer. The spacecraft sending these messages, one of the Voyager probes, was never designed to redefine our sense of scale. At the time of its launch, it had a more practical purpose. It was meant to visit the giant planets, take close-up images, measure their magnetic fields, sample their environments, and then, if everything went well, keep going. What no one could fully feel, even if they understood it mathematically, was just how long that keep going would last, and how much space there was still left after the last planet faded behind it. As Voyager travelled outward, something subtle began to happen. The familiar markers we used to measure distance stopped being useful. Millions of kilometres, then billions, became numbers that technically describe reality, but no longer helped anyone picture it. Even astronomical units, the distance between Earth and the Sun, started stacking up in ways that felt abstract rather than informative. This is where Voyager began to quietly reveal the true scale of the solar system, not through a single dramatic moment, but through patience, through year after year of movement without a rival, through the simple fact that it kept going, long after many expected the solar system to be over. One of the strangest things about deep space is how empty it feels, even when something is happening. Voyager did not pass through a sudden wall or a bright boundary marking the end of the sun's influence. There was no signpost, no sharp edge, no cosmic fence. Instead, the solar system thinned out gradually. The solar wind, that constant stream of charged particles flowing from the sun, grew weaker. The influence of our star became less dominant, more subtle, more easily disturbed by the environment beyond. From Earth, It is tempting to think of the sun as powerful and all-encompassing, a force that defines our entire cosmic neighbourhood, and in many ways, it does. But Voyager showed us that even the sun has limits, and those limits are spread across distances so large that they feel almost gentle rather than dramatic. The solar system does not end, it fades. As Voyager moved farther away, sunlight itself changed character. The warmth we take for granted diminished until it was no longer a meaningful source of energy. Darkness became the default. The spacecraft relied on the slow decay of radioactive material to keep its instruments alive, a tiny internal fire burning quietly while the surrounding space grew colder and quieter. There is something oddly comforting about that image. A small, steady source of power continuing to function in an environment that offers no help at all. Voyager does not hurry. It does not slow down in any way that feels noticeable. It simply continues, carrying with it the accumulated effort of thousands of engineers, scientists and technicians who knew they would never see its final destination, and still it sends its messages home. Each signal takes many hours to arrive. When Voyager transmits data, it does so knowing that Earth will not hear it until long after the spacecraft has moved on. In a sense, we are always listening to Voyager's past. What we receive now describes a place the probe was many hours ago, and by the time we process that information, it is already even farther away. This delay is one of the first ways Voyager forces us to confront scale, not through distance alone, but through time. Cause and effect are stretched. Now becomes fuzzy. The idea of real-time communication, something we're so used to, quietly stops applying, and yet despite this delay, the connection remains. Voyager is still part of our world, even as it leaves it behind. As the probe continued outward, scientists began to notice changes that hinted at something important. The behaviour of particles around Voyager shifted. The balance between solar material and interstellar material started to change. The environment was no longer dominated by the sun alone. This was not a sudden transition. There was no single moment when Voyager crossed a clean line from inside to outside. Instead, there was a long region where influences overlapped, where the sun's presence weakened and the galaxy's presence grew stronger. That overlapping region is vast, larger than the distance from the sun to any planet, larger than most people ever imagine when they hear the phrase, edge of the solar system. And Voyager drifted through it slowly, methodically, measuring conditions that no spacecraft had ever measured before. What those measurements revealed was unsettling in its simplicity. The solar system is not defined by planets. The planets are just small islands near the centre. The true size of the solar system is defined by how far the sun's influence reaches into space, and that reach extends far beyond Neptune, far beyond Pluto, and far beyond anything we can see with our eyes. This realization forces a quiet mental adjustment. If the solar system is this large, then the space between stars must be larger still, and if the space between stars is that vast, then our everyday sense of position, importance, and proximity begins to soften. Not disappear, but loosen. Voyager does not lecture us about this. It does not explain it in words. It simply keeps going, and in doing so, it asks us to notice how long going can last. There is something deeply human about following this journey. We launched Voyager at a time when optimism about exploration ran high, when the idea of reaching beyond known boundaries felt natural rather than overwhelming. But what Voyager has given us is not just data about space. It has given us a lesson in patience, in scale, in how small steps accumulate into distances that redefine entire concepts. As you lie there listening, it may help to imagine Voyager not as a machine racing through space, but as something drifting calmly outward, like a leaf carried by a very steady current. There is no urgency in its motion, no destination it must reach by a certain time, just forward movement, measured in years and decades rather than minutes or hours. That calm persistence is part of why Voyager's story fits so well here, in a place designed for rest. The probe does not demand attention, it invites it. You can think about it for a moment, then let the thought drift away, knowing it will still be out there, still moving, still quietly expanding the map of where here ends. Long before Voyager became a distant whisper at the edge of the sun's influence, long before it redefined how we picture the solar system, there was a single ordinary day on Earth when everything quietly began. Not with mystery or drama, but with checklists, weather forecasts, coffee cups cooling on desks, and people doing their jobs carefully, one decision at a time. This is often how history actually starts. Not with thunder, but with preparation. On that day, humanity did something simple and extraordinary at the same time. We built an object with no return ticket, placed it on top of a powerful rocket, and aimed it away from everything familiar. Then we let go. If you pause for a moment and picture Earth on that day, it helps set the scale of what was happening. The planet was busy being itself. People were going to work, arguing, laughing, worrying about bills, cooking meals, missing trains, and making plans for the weekend. Children were learning things that would later be outdated. Radios played songs that would eventually feel nostalgic. And meanwhile, on a stretch of coastline, a small group of people focused on a machine designed to leave all of that behind. Voyager was never meant to be a hero. It was a tool. A carefully engineered collection of instruments, wiring, shielding, and antennas assembled with the expectation that it would face conditions no human-built object had ever faced before: radiation, cold, emptiness, and time. A lot of time. The decision to send Voyager outward was rooted in a rare alignment of planets, something that happens only once every 176 years or so. The giant planets, Jupiter, Saturn, Uranus, and Neptune, had lined up in such a way that a spacecraft could visit them in sequence, borrowing a little energy from each one's gravity to fling itself onward. This technique, called a gravity assist, allowed a small probe to achieve what would otherwise require impossible amounts of fuel. Even knowing this, the plan was ambitious. The distances involved were already beyond everyday comprehension. Jupiter alone is hundreds of millions of kilometers away. Saturn is much farther still, and beyond them lay planets that, at the time, were barely more than fuzzy disks through telescopes. Voyager was built to survive the journey, but survival did not mean comfort. There would be no repairs, no upgrades, no second chances. Every component had to work not just once, but for years, maybe decades. The engineers knew that eventually something would fail. The only question was how much could be learned before that happened. And yet, woven into the technical goals was something quieter and more human. Voyager carried a message. Not a message in the usual sense of radio transmissions or coded data, but a physical artifact meant for anyone or anything that might one day encounter it. Attached to the side of the spacecraft was a golden record, protected by a cover etched with instructions on how to play it. On that record were sounds and images from Earth, music, greetings in dozens of languages, the sound of wind, thunder, laughter, a baby crying, a heartbeat. It is easy to dismiss this as symbolic or sentimental, but it represented something profound. We were not just sending a probe to gather information. We were sending a small piece of ourselves into the dark with no expectation of reply. Think about that for a moment. Voyager was designed to leave the solar system entirely, to travel through interstellar space for millions, even billions of years. Long after Earth itself may have changed beyond recognition, Voyager could still be drifting, carrying a record of who we were when we decided to reach outward. This was not done because anyone seriously expected it to be found. The odds are unimaginably small. Space is vast beyond anything we instinctively grasp. But the act itself mattered. It was a statement. We exist. We wondered. We reached. The launch itself was not silent. Rockets are loud, violent things. They shake the ground, fill the air with fire and pressure, and remind everyone nearby that escaping Earth's gravity is not a gentle affair. Voyager did not ease its way into space. It was forced upward, riding controlled explosions, shaking and rattling as it broke free from the planet that built it. Then, suddenly, the violence ended. Once the engines shut down and Voyager settled into its trajectory, the spacecraft entered a very different kind of journey. No more roaring thrust, no dramatic acceleration, just quiet motion, governed by gravity and momentum moving steadily away from the sun. At first, the distances grew quickly in human terms. Voyager passed the moon in hours. It passed Mars's orbit in days. Earth became a pale dot almost immediately. indistinguishable from countless other points of light. Communication delays grew from seconds to minutes, then longer. Still, everything felt close enough to manage. Engineers could send commands and expect responses within a reasonable time. Instruments were turned on and tested. Data flowed back. The solar system still felt like a place we understood. That feeling did not last. As Voyager continued outward, something subtle began to change in the way people talked about it. Timelines stretched. Milestones became measured in years instead of days. The probe would reach Jupiter in 2 years, Saturn a couple more after that. Uranus and Neptune would follow, but only after nearly a decade. This required a shift in mindset. People who worked on Voyager knew they were committing to a long relationship with a machine that would outlast many of their careers. Some would retire before the mission ended. Some would never see its final data return. And still, they continued. There is something quietly remarkable about that kind of commitment. To work on something knowing that its greatest discoveries might occur long after you've moved on. To trust that others will care enough to keep listening. As Voyager approached Jupiter, it sent back images that changed how we saw the giant planet forever. Storms larger than Earth, moons with active volcanoes, a world far more dynamic than anyone expected. Each discovery reinforced the idea that sending Voyager had been worth it. But even as these discoveries unfolded, Voyager was already doing something else. It was building momentum, not just physical speed, but narrative momentum. With every success, it became easier to justify letting it keep going. After Saturn, the original mission goals were technically complete. Voyager had done what it was sent to do. It had visited the giant planets and transformed them from distant points of light into complex worlds. At that point, many missions would have ended. Voyager did not. Instead, the decision was made to let it continue, to repurpose it as an interstellar probe, to see how far it could go and what it might encounter along the way. This decision, simple as it sounds, is what ultimately led to Voyager revealing the true scale of the solar system. Because up until that moment, the solar system was still mostly defined by planets, by orbits, by things that could be named and neatly categorized. Letting Voyager go meant accepting that the most interesting part of the journey might lie beyond all of that. As Voyager moved farther from the sun, sunlight weakened. Solar panels would not work here. Voyager relied instead on radioisotope thermoelectric generators, devices that convert the heat from radioactive decay into electricity. These generators provided a slow, steady supply of power, decreasing slightly each year. This imposed a kind of countdown. Instruments would eventually have to be turned off to conserve energy. Choices would be made about what to keep alive and what to let go. Voyager would not fail all at once. It would fade. And still, the signals would continue for as long as possible. Each transmission was a small act of defiance against distance, a radio signal spreading outward at the speed of light, thinning as it expanded until it reached Earth's antennas hours later, barely distinguishable from background noise. Listening to Voyager required patience and precision. Earth's receivers had to be pointed with incredible accuracy. The signal was weak, unimaginably so. And yet, with careful attention, it could be heard. There is something deeply fitting about that. A faint voice, travelling across billions of kilometres, carrying information about places no human has ever been, and probably never will be. A reminder that exploration does not always involve footsteps or flags. Sometimes it involves waiting, listening, and being willing to accept how small your presence really is. The day we launched Voyager, we did not yet know how empty the space beyond the planets truly was. We understood it mathematically, but not emotionally. Numbers alone cannot prepare you for years of travel without arrival, for distances that stretch patience as much as fuel. Voyager would teach us that lesson slowly. As it moved outward, the gaps between landmarks grew larger. The time between meaningful events lengthened, and gradually the solar system began to feel less like a collection of destinations and more like a vast continuous environment. This is an important shift. When we think in terms of destinations, we imagine endpoints, arrivals, finishing lines. But Voyager's journey revealed something else. The solar system is not a place you cross and then leave. It is a region that thins out, gradually giving way to something else. That realization did not come all at once. It emerged from years of steady data, from careful measurements of particles, fields, and radiation, from noticing that the sun's influence did not stop where the planets ended. And all of that began on the day we decided to throw a message into the dark. Not a message demanding attention, not a declaration of dominance, just a quiet introduction. Here we are. This is what we sounded like. This is what we valued enough to record. As Voyager continued outward, carrying that message with it, it became a kind of mirror. By watching it leave, we learned something about ourselves, about our patience, our curiosity, our willingness to invest in futures we may never personally witness. You might notice as you rest and listen that this story does not feel rushed. That is intentional. Voyager's journey does not reward hurry. It rewards persistence, the kind of persistence that continues even when progress feels almost invisible. In the distance between one signal and the next, between one year and another, Voyager kept moving, quietly, steadily, without needing applause or urgency. And in doing so, it prepared us for the next realization, one that would challenge some of our most comfortable assumptions about how space is arranged. Because once Voyager left the familiar neighborhood of planets behind, once the markers we relied on disappeared, it became impossible to ignore how misleading our mental maps had been. The solar system was not compact. It was vast, and we were only just beginning to feel how vast. That understanding did not arrive as a sudden revelation, but as a gradual stretching of perspective, one that would continue as Voyager pressed on, carrying its message farther and farther, while we stayed behind, learning how to listen across distances. At some point after the last close encounter with a planet, something subtle began to shift in the story Voyager was telling us. There was no announcement, no celebratory marker, no moment when engineers gathered around a screen and said, "This is it." Instead, the change revealed itself gradually, almost politely, as the familiar features of the solar system stopped appearing one by one. Up until then, space had still felt organized, even distant, even large. There were planets to aim for, names to say, orbits to calculate. There was a sense of progression, like moving from one neighborhood to the next, each with its own character. But once Voyager passed the outermost giant planets, that structure quietly dissolved. Imagine for a moment what it feels like to leave a place you know well. At first, the streets still look familiar. The buildings thin out, but you recognize the signs. Then the landmarks become fewer. You drive longer without seeing anything that tells you where you are. Eventually you realize that you're no longer going somewhere. You're simply moving away. That is what happened to Voyager. After Neptune faded behind it, the solar system stopped behaving like a collection of destinations and started behaving like a vast, continuous environment. The planets were no longer guides. The sun was still present, still influential, but its dominance was less obvious than it had been closer in. Space did not end. It opened. From Earth, this phase of the journey is easy to misunderstand. Textbook diagrams often show the planets neatly spaced, with the solar system ending shortly after the last orbit. Even when we add labels like Kuiper Belt or Oort cloud, they tend to feel like footnotes rather than defining features. Voyager taught us that this intuition is deeply misleading. The distance between planets is already enormous, but the distance beyond them is larger still, and more importantly, emptier. Not empty in the sense of nothingness, but empty of the kinds of objects our minds use to stay oriented. There are no large bodies passing close by, no dramatic flybys, no sense of arrival. This emptiness is not a failure of the mission. It is the message. As Voyager moved outward, it continued to communicate, but the nature of what it reported began to change. Instead of images of swirling clouds or ring systems, the data became quieter. Measurements of particle densities, magnetic field strengths, subtle variations in radiation. Information that does not immediately spark the imagination, but slowly builds a picture of where the sun's influence weakens. One of the first things to notice was how sunlight itself behaved. Even far from the sun, sunlight does not vanish. It fades. Its intensity drops according to a simple rule, spreading thinner and thinner as distance increases. By the time Voyager reached the outer regions beyond the planets, Sunlight was so weak that it no longer played a meaningful role in powering or warming the spacecraft. This is one of the reasons Voyager relied on internal power sources rather than solar panels. Out here, the sun is no longer a dependable companion. It is present, but distant, like a voice heard across a very large room. That fading presence matters because it helps define what leaving really means. Voyager did not cross a border where the solar system suddenly stopped working. It entered a region where the sun's influence became more subtle, more easily shaped by forces beyond. The familiar neighbourhood of planets is governed primarily by gravity and motion that feels predictable. Orbits follow paths we can calculate with confidence. The sun is unquestionably in charge. Beyond that region, other influences begin to matter more. The solar wind, a constant flow of charged particles streaming outward from the sun, still surrounded Voyager. This wind carries the sun's magnetic field with it, inflating a vast bubble around the solar system. Inside that bubble, conditions are shaped mainly by our star. Outside it, the galaxy asserts itself more strongly. But this bubble is enormous, much larger than the orbit of any planet, and Voyager would spend years moving through its outer reaches before anything clearly changed. During this time, communication delays continued to grow. Commands sent from Earth took longer to arrive, responses took longer to come back. Real-time interaction became impossible. Instead, engineers planned days or weeks ahead, sending sequences of instructions and then waiting patiently for confirmation that Voyager had followed them. This way of working requires trust. Trust in the spacecraft, trust in the models, trust that small decisions made far away will still make sense when they finally take effect. It also reinforces the reality of distance in a way that no number ever could. When you must wait nearly a full day to hear whether something worked, distance becomes part of your thinking. It shapes your expectations. It slows you down. As Voyager left the familiar neighbourhood, it also left behind the comforting illusion that space is busy. Near Earth, space feels crowded with satellites, signals and activity. Even near the planets, there are moons, rings and interactions. Beyond them, there is space on a different scale. Out here, events unfold slowly. Changes are measured over months and years. Nothing rushes. Nothing demands immediate attention. This slowness can feel unsettling if you expect constant progress, but it can also feel calming, especially when you allow yourself to match its pace. Voyager's instruments continue to sample the environment, recording the density and energy of particles it encountered. These measurements revealed that the region beyond the planets is not uniform. It has structure, subtle currents, boundaries that are not fixed but shift over time as the sun's activity rises and falls. This is another way Voyager reshaped our understanding. The solar system is not static, it breathes. The solar wind strengthens and weakens in cycles tied to the sun's behaviour. The boundary between solar influence and interstellar space moves inward and outward over years and decades. Leaving the familiar neighbourhood, then, does not mean leaving something stable behind. It means entering a region where change is slow, but constant. One of the most striking realizations during this phase is how small the planets become in retrospect. They dominate our attention because they are where things happen, where surfaces exist, where gravity shapes dramatic features. But in terms of space, they occupy a tiny fraction of the solar system's volume. If you could somehow compress the solar system into a form you could hold, the planets would be like dust motes near the centre. Everything else would be space-shaped by invisible forces, stretching far beyond what feels reasonable. Voyager moved through this space without ceremony. No fanfare marked the moment when Neptune's influence became negligible. No one could point to a specific day and say, "Now we are truly beyond." The solar system does not offer such clarity. Instead, there was a growing sense of separation. Earth became less immediate, the sun less dominant. The idea of home stretched into something more abstract. This is where Voyager's journey becomes less about exploration in the traditional sense and more about perspective. The spacecraft was no longer discovering new worlds, it was discovering scale, and scale, once truly felt, has a way of changing how everything else looks. From this distance, the inner solar system feels tightly packed. The journeys that once took years now seem almost short. The vastness beyond the planets reframes everything that came before. It also reframes our own position. Earth, which feels so large and complex from the inside, becomes one small participant in a much larger structure. Not insignificant, but not central in the way our daily experience suggests. Voyager does not make this point directly. It simply continues outward, carrying its instruments and its message, letting the distance accumulate. As the probe moved farther from the sun, the solar wind began to show signs of slowing. Its pressure weakened. Interactions with the surrounding interstellar medium became more noticeable. Voyager was approaching a region where the sun's outward push would eventually be balanced by the pressure of space between the stars. This region is vast. Crossing it would take years, and Voyager would do so at the same steady pace it had maintained since launch, without acceleration, without rest. There is something quietly reassuring about that consistency. Voyager does not react emotionally to leaving the familiar neighbourhood. It does not hesitate or look back. It simply follows the path set for it long ago. For those listening now, resting and letting the story unfold, this part of the journey offers an invitation to slow down. To notice how much of our sense of importance comes from proximity. From being near things we recognise and understand. When those things fall away, what remains is not emptiness, but context. Leaving the familiar neighbourhood did not make Voyager lost. It made Voyager free from the need for destinations. Its purpose shifted from reaching places to revealing how much space lies between them. And as it continued outward, the idea of an edge began to feel less like a wall and more like a gradient. Something you move through gradually without noticing the exact moment it happens. Before Voyager ever slipped into the quieter, emptier reaches beyond the planets, there was a long stretch of travel that felt purposeful, almost busy by comparison. The path outward first led toward the giants, the enormous outer worlds that hold most of the solar system's planetary mass. Reaching them was not a short hop. It required patience measured in years, not weeks, and during that time the spacecraft experienced something that is easy to forget when we look back at the mission as a single continuous arc. It had to cross a great deal of space just to reach the first destination. When Voyager left Earth, it did not head straight toward Jupiter like a car driving down a clear road. Instead, it entered a carefully calculated trajectory shaped by gravity, timing, and opportunity. Earth's gravity released it. The rocket's upper stage gave it a final push. Then the sun took over, bending Voyager's path into a long outward curve. From our perspective on Earth, Jupiter feels like part of the same celestial family. We see it in the night sky. We give it a familiar name. But in terms of distance, Jupiter is far beyond anything human beings had ever physically visited before. The gap between Mars and Jupiter alone contains hundreds of millions of kilometres. Even travelling at speeds that would outpace any aircraft ever built, Voyager needed nearly 2 years to arrive. 2 years is an interesting length of time. Long enough for jobs to change, for governments to shift, for new technologies to appear. While Voyager crossed the space between Earth and Jupiter, life on Earth continued at its usual restless pace. The probe, meanwhile, moved steadily, unbothered by headlines or seasons. This crossing itself began to hint at scale. The inner solar system, where the rocky planets orbit, is relatively compact compared to what lies beyond. Once Voyager passed Mars's orbit and entered the asteroid belt region, it was no longer travelling between crowded neighbours. It was traversing space that, despite its dramatic name, is mostly empty. Popular imagination once pictured the asteroid belt as a dense field of tumbling rocks that a spacecraft would need to dodge carefully. In reality, the objects are separated by vast distances. Voyager passed through without incident. There were no close calls, no cinematic evasions, just more space. That theme would repeat again and again. Our intuitions, shaped by diagrams that compress distances for convenience, would prove unreliable. As Jupiter grew brighter in Voyager's instruments, anticipation built on Earth. This would be the first close look at the largest planet in the solar system, from a spacecraft equipped with cameras and sensors far more advanced than those used before. Jupiter is not just large. It is massive enough that its gravity influences everything around it. Its magnetic field is immense. Its system of moons is complex. Approaching Jupiter was like approaching a small solar system within the solar system. The gravity assist maneuver that awaited Voyager was both elegant and powerful. By flying close to Jupiter, The spacecraft could steal a tiny fraction of the planet's orbital momentum. Jupiter would lose an imperceptible amount of speed in its path around the Sun. Voyager would gain a tremendous boost, slingshotting outward faster than any rocket could have propelled it alone. This exchange is a reminder that even in the apparent emptiness of space, motion is shared. Energy moves between bodies, nothing is isolated. The flyby of Jupiter revealed storms larger than Earth, lightning flashes in alien clouds, and moons that were anything but quiet. One of those moons, Io, turned out to be volcanically active, with plumes rising hundreds of kilometers above its surface. This was a surprise. It forced scientists to reconsider what active means in the outer solar system. But even as images streamed back and discoveries were catalogued, Voyager was already moving past Jupiter. The encounter was brief in cosmic terms. A few months of approach, a few intense days of closest observation, and then the spacecraft was flung onward. That slingshot marked a turning point in speed. Voyager was now travelling fast enough to escape the Sun entirely. It would not loop back. It would not settle into orbit. Its path was outward and permanent. Next came Saturn, another giant world with its own complexity. The journey from Jupiter to Saturn took additional years, though the gravity assist had shortened what would otherwise have been an even longer crossing. During this phase, Voyager travelled through regions of space that, once again, felt vast and largely featureless. Communication delays grew steadily. Signals that once took tens of minutes now required over an hour each way. Engineers learned to think ahead, to plan carefully, to accept that quick corrections were no longer possible. Saturn's rings, delicate and structured, offered another moment of concentrated attention. Voyager revealed fine details, gaps, waves, and small embedded moons shaping the rings through gravity. Titan, Saturn's largest moon, drew particular interest because of its thick atmosphere. Yet once more the pattern repeated. Arrival, discovery, departure. After Saturn, the mission faced a branching possibility. One Voyager probe was directed toward Uranus and Neptune, taking advantage of the rare planetary alignment. The other would follow a different path. Each option required precise timing. Missing a window by even a small margin would change everything. The crossing to Uranus was especially long. Uranus lies nearly twice as far from the Sun as Saturn does. The distance between them is measured not just in millions, but in billions of kilometers. Travelling that far meant waiting years for the next close encounter. It is difficult to truly grasp how empty that path was. No planets to observe, no dramatic gravitational dances, just the spacecraft and the Sun separated by an ever-growing gulf. When Voyager finally reached Uranus, it found a world tilted dramatically on its side, with a faint ring system and moons that appeared dark and cold. Neptune followed, even farther still with its own deep blue hue and powerful winds. Neptune was the last of the giant worlds. Beyond it lay no more major planets. Pluto, though now classified differently, was not part of Voyager's trajectory. After Neptune, there would be no more dramatic planetary flybys. Looking back, the long crossing to the giant worlds served two purposes. It gave us detailed knowledge of these distant planets, transforming them from vague points of light into places with character and activity. But it also quietly prepared us for something else. It taught us how far apart things really are. The gap between Jupiter and Saturn alone is greater than the distance from Earth to the Sun. The gap between Saturn and Uranus is larger still. Each crossing stretched our patience, forced our calculations to adjust, and reminded us that space is not scaled to human convenience. During these years, Voyager's speed relative to the Sun remained extraordinary. It was moving faster than any human-made object had before, and yet, even at that speed, years passed between major events. This is the lesson that numbers often fail to convey. Even when travelling faster than anything we have ever built, the solar system does not shrink into something manageable. It remains expansive, resistant to compression in the imagination. By the time Voyager completed its encounters with the giant planets, it had effectively demonstrated that the inner solar system is only a small portion of the Sun's domain. The true extent lay far beyond. The gravity assists had given Voyager the energy needed to leave the familiar structure of planetary orbits behind. Its trajectory was now aimed toward the outermost regions shaped by the Sun's influence. a region far less visible and far more extended. In a sense, the long crossing to the giant worlds was the last phase in which Voyager's journey resembled a traditional expedition. There were targets, close passes, bursts of imagery. Beyond that, the mission would transform into something slower and more abstract. As you rest and follow this story, it may help to picture those long crossings not as empty stretches, but as demonstrations. Demonstrations of how little our everyday sense of distance applies beyond Earth. Demonstrations of how persistence matters more than speed when the scale is this large. Voyager did not rush. It could not. It moved at extraordinary speed by human standards, yet the solar system absorbed that speed effortlessly, offering more space, more distance, more room to travel. And when Neptune finally fell behind, the crossing to the giant worlds was complete. The solar system no longer presented recognizable landmarks ahead. At a certain point in Voyager's journey, something quietly deceptive revealed itself. It wasn't a discovery announced in a press release or a sudden change in instrument readings. It was a realization that crept in slowly, almost uninvited as years passed and the spacecraft continued to move without encountering anything new or familiar. The planets, it turned out, had always been misleading us. Not in their behavior, and not in their physics, but in how close together we imagine them to be. From childhood onward, most of us are introduced to the solar system through images that are designed to be helpful, not accurate. The Sun sits comfortably in the centre, surrounded by neat rings. Mercury, Venus, Earth, Mars, then the giants further out. Everything fits on a single page. Sometimes Pluto hangs at the edge like a shy afterthought. The message is subtle but powerful. The solar system is something you can take in at a glance. Voyager dismantled that illusion, not by arguing with it, but by simply travelling through the space those diagrams quietly erase. Between each planet lies an emptiness that is difficult to emotionally register until something has to cross it. When Voyager left one planet behind and began the long coast toward the next, the wait was not a pause in the mission, it was the mission. Months turned into years. Telemetry arrived steadily, but nothing about the environment changed in a way that felt dramatic. Space looked like space. The sun grew dimmer, the spacecraft kept moving. And this happened again and again. The illusion of planetary closeness comes from compression. To show all the planets on one page, the distances must be squeezed until they are no longer meaningful. Jupiter ends up looking like a near neighbour of Mars. Saturn appears just a short hop away from Jupiter. Uranus and Neptune seem like distant cousins, but still part of the same immediate family. Voyager showed us that this family is spread across an enormous territory. Consider this gently. If Earth were reduced to the size of a grain of sand, the Moon would be several centimetres away. That already feels farther than most people expect. Now imagine Jupiter on that same scale. It would be hundreds of metres away. Saturn would be nearly twice that distance. Uranus and Neptune would be separated by distances measured in kilometres, and beyond them there would still be nothing for a very long time. When Voyager crossed those distances, it did so at speeds that no human vehicle had ever achieved. Faster than bullets, faster than any spacecraft before it. And still, the time required was immense. This is the first crack in the illusion. Speed does not rescue you from scale. The second crack comes from repetition. Once, you might forgive a long crossing as an anomaly. Twice, it becomes a pattern. By the time Voyager had completed multiple multi-year crossings between planetary encounters, it became impossible to deny that the solar system is not a cluster of nearby objects, but a sparse distribution of islands embedded in a sea of space. The planets dominate our attention because they are where things happen. They have surfaces, storms, rings, and moons. They offer contrast. Between them, space offers almost none of that. No horizons, no textures, no markers to tell you how far you've gone. Voyager did not pass signposts that said halfway to Saturn or entering Uranus's neighbourhood. It simply moved and the numbers in mission logs increased steadily. From Earth, those numbers feel abstract. Millions of kilometres, billions, astronomical units stacked on top of each other. But for the spacecraft, there was no abstraction. Every metre had to be crossed. The illusion of closeness also comes from how quickly we can name the planets. We can list them in seconds. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The ease of that list hides the enormity of the space between each word. Voyager gave time back to those gaps. As the spacecraft travelled farther from the Sun, another subtle effect reinforced this lesson. Communication delays increased steadily. Early in the mission, commands could be sent and responses received within manageable timeframes. By the time Voyager was crossing the outer planetary distances, every interaction became a long conversation with silence built in. You would send a command, then you would wait, and only later would you learn whether the spacecraft had received it and responded correctly. This enforced patience mirrors the physical reality of the distance involved. You cannot rush a signal across billions of kilometers. You cannot shorten the gap by wanting it to be smaller. The illusion of planetary closeness also affects how we think about the Sun's influence. We often imagine that the planets neatly define the solar system, that once you pass the last planet, you are more or less outside. Voyager demonstrated how deeply wrong that assumption is. The planets occupy only the innermost portion of the Sun's domain. They are like bright beads near the centre of a much larger structure. Beyond them, the Sun's influence continues, shaping space in quieter, less visible ways. The solar wind does not stop at Neptune. The Sun's magnetic field does not end with the last orbit. These effects extend outward for distances that dwarf the planetary system itself. This means that even as Voyager left Neptune behind, it was still very much within the solar system. It was nowhere near the true boundary. The illusion that the planets mark the edge fell apart completely. Another contributor to this illusion is the way time is presented in mission summaries.
We might read that Voyager reached Jupiter in 2 years, Saturn a couple of years later, Uranus and Neptune after that. The years blend together. The waiting disappears into a sentence. Living through that waiting is different. For the engineers and scientists tracking Voyager, years passed between major milestones. Careers advanced, teams changed. New generations of scientists joined projects that had begun before they finished school. The mission became something that outlived individual expectations. This human timescale contrast further emphasized how misleading our intuitive maps are. If something takes years to reach at record-breaking speed, it is not close in any meaningful sense. Voyager also highlighted how much of the solar system's volume contains almost nothing detectable. This does not mean it is truly empty. There are particles, fields, dust, and radiation, but these are not things our senses evolved to notice. We are drawn to objects, to surfaces, to things we can point at. The vast majority of the solar system offers none of that. Between planets, there is space so empty that even a spacecraft can travel for years without encountering anything that demands attention. No collisions, no dramatic interactions, just steady motion through a thin environment. This emptiness is part of why the illusion persists. We are not good at appreciating what we cannot see or touch. Voyager made the invisible visible through persistence, through data that accumulated slowly.
Through long stretches where nothing happened in the way we're accustomed to defining events. As you rest and listen, there is something calming about this realization. The solar system is not crowded, it is spacious. It allows things to drift, to move without urgency. The illusion of closeness collapses further when you consider how small the planets themselves are compared to the distances between them. Even Jupiter, enormous by planetary standards, occupies a tiny fraction of the space it sits within. If the solar system were a city, the planets would be small houses separated by vast fields, forests, and empty land. You would not walk from one to the next. You would travel for days, perhaps weeks, without seeing another structure. Voyager did exactly that. This realization matters because it reframes how we think about exploration. Reaching another planet is not like visiting a nearby country. It is more like crossing an ocean so large that the departure point fades from memory before the destination appears, and even then, that destination is brief. Voyager's encounters with planets were intense but short-lived. Days or weeks of focused observation, followed by years of travel. The imbalance is striking. The waiting dominates. The events punctuate it. This pattern is not accidental. It is built into the structure of the solar system itself. By the time Voyager had completed its planetary tour, the illusion of closeness had been thoroughly dismantled for those paying attention. The planets no longer felt like a tight-knit group. They felt like widely spaced milestones along an immense path. This understanding sets the stage for what comes next. If the planets are this far apart and if they occupy only the inner portion of the solar system, then the regions beyond them must be larger still. The solar system is not defined by the spacing of its planets. It is defined by the reach of its star, and that reach extends into regions where even Neptune begins to feel like a neighbour rather than an outpost. Voyager's slow, steady crossing between worlds was not just travel. It was a lesson delivered 1 kilometre at a time, a correction to the tidy diagrams, a reminder that convenience and accuracy are rarely the same thing. As Voyager continued outward, leaving planetary orbits behind entirely, this lesson would deepen. The idea of closeness would lose meaning altogether. Distances would no longer be framed by objects at all, but by changes in the environment itself. For now, it is enough to let the illusion fall away gently. The solar system is vast. The planets are far apart, and Voyager, by simply taking the time to move between them, showed us that our mental shortcuts had always been hiding the true scale. A scale that would become even more apparent as the familiar landmarks faded and the sun's domain stretched on, far beyond anything those early diagrams ever suggested. There comes a stage in Voyager's journey when the sun begins to change character. Not suddenly, and not in a way that would be obvious if you were standing beside the spacecraft, but gradually, as distance accumulates and familiarity loosens its grip. The sun does not disappear. It does not shrink into nothing. Instead, it slowly loses its authority. Closer in, the sun defines everything. It is the source of light, warmth, gravity, and motion. The planets move to its rhythm. Space itself feels arranged around it. Even when you cannot see it directly, you feel its presence in every calculation, every orbit, every shadow. Farther out, that certainty softens. By the time Voyager had passed beyond the giant planets and continued into the quieter reaches, the sun was no longer the overwhelming presence it once had been. It still dominated gravity locally. It still filled the sky with light, but it no longer felt unique. It began to resemble something else entirely. It began to resemble a star. This shift is one of the most difficult to feel from Earth, because we live so close to the sun that it defines our experience of space completely. Our days are structured around it. Our climate depends on it. Our very language treats it as singular. The sun rises. The sun sets. The sun shines. Voyager revealed something quietly unsettling. Out there, the sun is not special in the way it feels from here. It is one star among many, surrounded by others that are just as real, just as massive, and sometimes far more powerful. This realization does not arrive all at once. It emerges through subtle measurements and slow changes. One of the earliest indicators comes from light itself. Sunlight spreads outward in all directions, thinning as it goes. This follows a simple physical rule. Double the distance and the light spreads over 4 times the area. Triple the distance and it spreads over 9 times the area. By the time Voyager reached the outer reaches beyond the planets, sunlight was no longer a dominant force. There was still light, of course, enough to be measured, enough to be detected, but not enough to matter in the way it once did. Voyager did not rely on sunlight for power. It could not. Solar panels would have been useless at these distances. Instead, the spacecraft carried its own internal energy source, slowly converting heat from radioactive decay into electricity. That quiet, steady power allowed Voyager to function in an environment where sunlight was more of a background glow than a driving force. This is the first way the sun begins to feel ordinary. When it is no longer the primary source of energy, it becomes one influence among many. Another change comes from the sky itself. Near Earth, the sun dominates the sky. Even when it is not visible, its brightness shapes everything. The stars fade during the day. The moon reflects its light. Shadows exist because of it. Far from the sun, the sky becomes different. The sun still shines, but it no longer overwhelms the stars. Starlight becomes more noticeable. The background of the galaxy grows more present. If you could somehow look up from Voyager's position, the sun would no longer command attention. It would appear as a bright point, yes, but not dramatically different from other bright stars. Sirius, Vega, and others would share the sky on more equal terms. This is not because the Sun has changed. It is because perspective has. The Sun's apparent importance is a function of distance. Move far enough away, and its uniqueness fades. Voyager carried that perspective outward, kilometre by kilometre, year by year. There is something quietly humbling about this. From Earth, the Sun feels like the centre of everything. From far away, it becomes one object in a crowded galaxy. Voyager's instruments also detected changes in the particles surrounding it. The solar wind, that continuous stream of charged particles flowing outward from the Sun, grew weaker as distance increased. Its density dropped, its pressure diminished. Closer in, the solar wind dominates space. It pushes outward relentlessly, shaping the environment. But farther out, it begins to encounter resistance. Particles from interstellar space push back. The Sun's influence no longer expands freely. It negotiates. This interaction marks the beginning of a transition. The space around Voyager was no longer shaped exclusively by the Sun. The galaxy was beginning to assert itself. This is another way the Sun becomes just another star. Its influence meets limits. It competes with the collective environment between stars, an environment shaped by countless suns over immense periods of time. The Sun still matters. Its gravity still holds the planets. Its wind still flows, but it no longer feels alone. From Earth, it is easy to forget that the Sun is not isolated. It exists within a galaxy filled with stars, gas, dust, and magnetic fields. We rarely feel that context because the Sun's influence shields us from it. Voyager moved beyond that shield. As the spacecraft continued outward, measurements showed increasing signs of the interstellar medium. This medium is not empty. It contains sparse gas, charged particles, and magnetic fields that permeate the galaxy. It is shaped by ancient supernovae, stellar winds from other stars, and the slow circulation of matter through the Milky Way. Inside the Sun's domain, this interstellar environment is pushed aside. Outside, it dominates. Voyager was approaching the region where these two influences meet, a place where the Sun's outward pressure balances the inward pressure of the galaxy. This boundary is not sharp. It is not a wall. It is a broad, shifting region that responds to changes in solar activity and the surrounding interstellar environment. Voyager would take years to traverse it. During this time, the Sun's identity continued to change. It was no longer the unquestioned ruler of space. It became a participant in a larger system. This realization has consequences for how we think about the solar system itself. If the Sun is just one star among many, then the solar system is not a unique island floating in isolation. It is a small bubble carved into a much larger structure. From Voyager's perspective, the solar system began to feel less like a complete system and more like a local variation within the galaxy. A region where one star's influence temporarily dominates, before blending back into the general environment. There is something comforting in this, even if it feels unsettling at first. The Sun does not lose its importance to us. It still defines our lives, but it gains context. It becomes part of something larger. This context matters because it reframes distance. The distances Voyager travelled within the solar system were enormous by human standards, but compared to the distances between stars, they were modest. As the Sun became just another star, the scale of the galaxy began to assert itself in Voyager's data. The environment no longer reflected a single source of influence. It reflected a collective one. Another subtle effect of this transition involves time. Near Earth, changes in solar activity can be felt relatively quickly. Solar storms affect satellites. Solar cycles influence space weather. Farther out, those changes arrive later, diluted and altered by distance. Voyager detected variations in the solar wind that reflected events at the Sun many months earlier. Cause and effect were stretched across vast distances. The Sun's actions echoed outward long after they occurred. This delay further weakened the sense of immediacy. The Sun was no longer something happening now. It became something that had happened long ago, with effect still rippling outward. That sense of temporal distance mirrors the physical distance. the sun's presence became something you inferred rather than experienced directly. As Voyager continued, the stars themselves became more meaningful reference points. The spacecraft's position could be described relative to the sun, but also relative to the surrounding galaxy. The Milky Way was no longer just a backdrop, it was an environment. This is another moment where our intuition struggles. We are used to thinking of the solar system as a complete thing. Voyager showed us that it is more like a neighbourhood within a city. The sun is our local star. Its planets are its immediate companions. But beyond them lies a shared space shaped by many stars together. There is no ceremony when this realization settles in. It arrives quietly, through data and patience. For those listening now, resting and letting the words move at an unhurried pace. This part of the journey offers a gentle shift in perspective. The sun does not disappear. It simply steps back. Its warmth, which once defined the spacecraft's environment, becomes negligible. Its light, once dominant, becomes one glow among many. Its wind, once uncontested, meets resistance. And yet, Voyager continues to carry the sun's story with it. The golden record, the signals, the knowledge that this small machine was built around a star that nurtured life intelligent enough to wonder about scale. In that sense, the sun remains central, even as it becomes ordinary. This is not a contradiction. It is a layering of meaning. The sun is central to us. It is not central to the galaxy. Voyager's journey allows both truths to exist at once. As the sun's dominance softened, Voyager approached regions where measurements would reveal the true boundary of its influence. Regions where the transition from solar to interstellar would become unmistakable. But before that boundary could be reached, Voyager had to spend years in a space shaped by diminishing sunlight and increasing galactic presence. A space where the sun still mattered, but no longer defined everything. Far from home, the sun becomes just another star, and in doing so, it reveals not a loss of importance, but a gain in understanding. A clearer picture of where we are, how far we extend, and how small our local brightness is within the vast, patient glow of the galaxy, which Voyager continues to approach, one steady moment at a time. Out beyond the last familiar glimmer of planetary light, where orbits no longer offer signposts and the sun no longer fills the sky with authority, Voyager entered a kind of space that feels emotionally different, even if the physics changes only gradually. This is the region where home does not vanish, but slowly loosens its hold, and warmth becomes something remembered rather than felt. From Earth, warmth is so constant that it fades into the background of daily life. The sun rises, the air heats, seasons shift, and we adjust without ever thinking about how dependent we are on that steady stream of energy. Even far from the sun, as long as you remain among the inner planets, sunlight still feels like a given. It might be weaker, but it is always there, filling space with light and heat. For Voyager, that assumption quietly stopped being true. As the spacecraft continued outward, the sun's warmth diminished in a way that was not dramatic but relentless. There was no moment when heaters shut off or temperatures suddenly plunged. Instead, every kilometre placed between Voyager and the sun meant slightly less energy arriving, slightly fewer photons, slightly less influence. This fading is governed by simple geometry. Light spreads outward in all directions, and as it does, it thins. By the time Voyager had moved beyond the giant planets, sunlight was already many times weaker than what Earth receives. Beyond Neptune, it became so faint that it no longer played any meaningful role in the spacecraft's survival. Voyager was never warmed by the sun in the way a planet is. It carried its own heat source, generated by the slow decay of radioactive material inside special power units. These radioisotope thermoelectric generators produce both electricity and warmth, allowing instruments to function in an environment where external heat was scarce. Still, the sun's fading mattered. Not because Voyager needed it to survive, but because its absence marked a psychological boundary in how we think about space. Closer to home, the sun feels like an anchor. Its warmth is a reminder that you are still within reach, that the environment, however harsh, is shaped by something familiar. As that warmth fades, the environment begins to feel less like an extension of home and more like something else entirely. For Voyager, temperatures dropped steadily. Space itself is not cold in the way we experience cold on Earth. There is no air to steal heat from your skin. But objects radiate their heat away into the darkness, and without an external source of energy to replenish it, everything trends toward equilibrium with the background of space. That background is only a few degrees above absolute zero. Voyager's internal systems were carefully insulated and designed to retain heat where it was needed most. Even so, engineers had to make constant decisions about which instruments could remain active, and which would eventually have to be turned off to conserve power and warmth. This process did not happen all at once. Over the years, as the radioactive fuel slowly lost strength, instruments were shut down one by one. Cameras were turned off, certain sensors went silent. Voyager did not fail. It simplified. Each shutdown was deliberate. Each represented a choice to preserve the mission's core functions for as long as possible. Communication, navigation, and the ability to measure the surrounding environment were prioritized. Everything else became optional. This gradual fading mirrors the fading warmth of home itself. There is no clean break, no single farewell, just a steady reduction in what remains. The sun's warmth also influences the space around Voyager in subtler ways. The solar wind carries not only particles, but energy. As that wind weakens with distance, the environment becomes calmer in some respects and more exposed in others. Near Earth, the sun's influence shields us from much of the galaxy's background radiation. Its magnetic field deflects charged particles from distant cosmic sources. Farther out, that protection thins. Voyager detected changes in radiation levels that reflected this shift. Galactic cosmic rays became more prominent as the sun's shielding weakened. These high-energy particles, born from supernovae and other violent events far beyond our solar system, penetrated deeper into the region Voyager occupied. This is another sense in which warmth fades. Not just thermal warmth, but the comforting dominance of a single influence. The sun no longer set the tone for everything. The galaxy began to speak more clearly. From Earth, it is easy to imagine that space beyond the planets is simply colder and darker. Voyager showed us that it is also more exposed, less sheltered, more honest in a way. The fading warmth of home also reveals itself in time. Signals sent from Earth took longer and longer to arrive. Instructions that once felt immediate became delayed. Voyager existed increasingly in a different now than we did. When engineers sent commands, they were sending them into the past relative to Voyager's current position. When Voyager replied, it was describing conditions that no longer existed by the time we heard about them. This separation adds another layer to the idea of fading warmth. Home is not just a place, it is a shared sense of time. As that synchronization weakened, Voyager became more alone, and yet it was never abandoned. Earth continued to listen. Large antennas tracked the spacecraft's faint signal. The Deep Space Network adjusted its receivers, filtering noise, compensating for motion, and amplifying whispers into data. That act of listening across such distance is itself a kind of warmth, not physical, but intentional. Voyager's environment grew colder and quieter, but the connection remained. Another subtle effect of distance involves perspective. Near the sun, its light dominates the sky. Farther out, darkness becomes the default. The stars emerge more clearly. The Milky Way becomes less of a background concept and more of an environment. If Voyager could see in the way we do, the sun would no longer cast sharp shadows. Its light would no longer overwhelm the sky. It would simply be one bright point among many. This shift is important because it marks a psychological transition. The sun is no longer something you are inside of. It is something you are leaving behind. For humans, leaving warmth behind carries emotional weight. Warmth is associated with safety, life, and familiarity. Cold suggests distance, isolation, and endurance. Voyager embodied that endurance. The spacecraft did not react to the fading warmth. It did not slow down or falter. It continued on the same trajectory, powered by its internal sources, designed from the beginning to survive where sunlight could not help it. This design choice was not accidental. The engineers who built Voyager understood that the most interesting part of the journey might occur long after the sun ceased to be useful as a resource. In doing so, they acknowledged something profound. Exploration does not always move toward comfort. Sometimes it moves away from it. As Voyager travelled farther, the idea of home became increasingly abstract. Earth was no longer a place you could meaningfully point toward and say, there. It was a concept, a memory encoded in signals and records. The golden record aboard Voyager became more symbolic in this context. It carried sounds and images from a warm, active world, preserved on a spacecraft drifting through an environment where warmth was scarce. This contrast is striking. Laughter, music, greetings, and heartbeats recorded on a machine that would spend most of its existence in near absolute cold. And yet, that contrast is honest. It reflects the reality of our place in the universe. Warmth is rare, life is fragile, distance is vast. The fading warmth of home also prepares us to think differently about scale. Temperature is not just a measure of heat, it is a measure of proximity to energy sources. Near a star, warmth is abundant. Far from it, energy must be carried within. Voyager carried its warmth with it. As you rest and listen, there is something quietly grounding about this idea. The spacecraft does not complain about the cold. It does not resist it. It was built with the expectation that warmth would fade, and it adapted accordingly. That expectation mirrors a broader truth. Our sense of comfort is local. Our assumptions about safety and familiarity are shaped by where we evolved. The universe is under no obligation to provide them elsewhere. Voyager's journey through the fading warmth is not a story of loss. It is a story of transition, of adjusting to an environment that does not cater to life or ease. The sun still mattered. Its gravity still shaped Voyager's path. Its wind still flowed outward. But its warmth no longer defined the spacecraft's existence. This is the moment when the solar system begins to feel less like an extension of home, and more like a region being passed through. Ahead lay boundaries that would be defined not by temperature, but by pressure, particles, and magnetic fields. Boundaries where the sun's influence would be measured against the galaxy itself. Before reaching those regions, Voyager had to spend years in a space where warmth was fading but not gone, where home was distant but not forgotten. This in-between state is important. It teaches patience, it teaches adaptation, it teaches us that leaving does not happen all at once. For Voyager, the fading warmth of home was not an ending. It was preparation, a gradual acclimation to an environment where survival depended entirely on internal resilience rather than external support. If you imagine the solar system as a tidy structure with a clean outer wall, this is the moment when that picture quietly falls apart. There is no fence, no glowing boundary line, no sudden drop from inside to outside. What Voyager approached was something far more subtle, and in many ways, far more interesting. For centuries, people naturally assumed that systems must end the way objects do. A shoreline marks the end of land. A city limit sign marks the end of a town. Even a planet has a surface you can point to and say, here is the boundary. It feels intuitive that the solar system should have something similar, a final edge beyond which it simply stops. Voyager revealed that this expectation is misleading. The sun does not draw a hard line in space. Instead, it creates a sphere of influence that thins gradually as distance increases. That sphere is shaped not just by gravity, but by the solar wind, the continuous stream of charged particles flowing outward in all directions. Think of the solar wind as a slow, invisible exhale. The sun releases it constantly, and it expands outward into interstellar space, carrying the sun's magnetic field with it. This outflow forms a vast bubble around our star, a region where the sun's influence dominates over the surrounding galaxy. That bubble is called the heliosphere. The heliosphere is not small. It extends far beyond the orbit of Pluto, far beyond the Kuiper Belt, and into a region that Voyager would take decades to reach. It is shaped by the balance between the outward pressure of the solar wind and the inward pressure of the interstellar medium, the sparse gas and particles that fill the space between stars. Where these pressures meet, something interesting happens. The solar wind slows down, its particles pile up slightly, its motion becomes less smooth, but it does not stop instantly. This is why the edge of the solar system is not an edge at all. It is a transition zone, a broad, shifting region where the sun's influence gradually yields to that of the galaxy. As Voyager travelled outward, its instruments began to detect changes in the solar wind's behaviour. Speeds decreased, particle densities fluctuated, Magnetic fields twisted in subtle ways. These changes did not happen overnight. They unfolded over years. The first major region Voyager encountered in this transition is called the termination shock. This is the point where the solar wind, which has been racing outward at supersonic speeds, slows abruptly due to pressure from the interstellar medium. Shock might suggest something dramatic like a collision. In reality, it is more like traffic slowing down as it approaches congestion. The particles compress, adjust and continue, but at reduced speed. Voyager crossed this region quietly. There was no jolt, no visible marker, only instrument readings showing that something fundamental had changed. Beyond the termination shock lies the heliosheath. This is a vast region where the solar wind continues outward, but more slowly and more turbulently. It is like a buffer zone between the inner heliosphere and the true boundary with interstellar space. Voyager spent years crossing the heliosheath. This fact alone challenges our sense of scale. Years inside a boundary region. Years moving through a zone that, in a simple diagram, might be drawn as a thin line. The heliosheath is not thin. It is enormous, and its size is not fixed. It expands and contracts depending on the sun's activity. During periods of high solar output, the heliosphere swells. During quieter periods, it shrinks. This means that the edge of the solar system is dynamic. It breathes. Imagine trying to define the edge of a cloud while it shifts shape constantly. Any boundary you draw would be temporary. Voyager's measurements during this time were crucial. They showed that the heliosphere is not smooth or uniform. It contains variations, ripples, and fluctuations driven by both solar activity and the surrounding interstellar environment. The spacecraft detected changes in particle populations. Galactic cosmic rays became more prominent as the solar wind's shielding effect weakened. The balance between solar origin particles and interstellar origin particles shifted gradually. Still, there was no clear moment of departure. Engineers and scientists watched the data carefully, waiting for signs that Voyager had reached the Heliopause, the boundary where the solar wind's outward push is finally balanced by the inward pressure of the interstellar medium. Even that boundary is not sharp. The Heliopause marks a region where the density and composition of particles change noticeably. Solar particles drop off, interstellar particles increase, magnetic field orientations adjust. Voyager eventually crossed this region, but even then the transition was not visually dramatic. It was inferred from data. A shift in particle counts, a change in magnetic field characteristics, a measurable increase in cosmic rays. This subtlety is important. The solar system does not end with a bang. It fades into the galaxy. From Earth, we tend to think in binaries, inside or outside, here or there. Voyager's journey forces us to adopt a gradient instead. This gradient reshapes how we understand our place in space. If there is no clear edge, then the solar system is less like a walled garden and more like a region of influence within a larger environment. That larger environment, the interstellar medium, is not empty. It contains gas atoms, charged particles, and magnetic fields shaped by countless other stars. It is the shared space of the galaxy. Voyager's crossing into this region marked the first time a human-made object entered true interstellar space, but even that statement requires nuance. Voyager is still gravitationally bound to the Sun. Its trajectory is shaped by the Sun's pull. It will orbit the centre of the Milky Way alongside our star for billions of years. So in one sense, it is still part of the solar system. In another, it has left the Sun's direct plasma environment. This ambiguity reinforces the idea that the edge is not an edge. It depends on what you mean by solar system. If you define it by planets, Voyager left long ago. If you define it by the heliosphere, it crossed more recently. If you define it by gravity, it has not left at all. Boundaries in space are often conceptual rather than physical. There is something quietly calming about this realization. The universe does not organize itself into neat categories for our convenience. It transitions gradually, blending one region into another. As Voyager moved through the heliosheath, signals continued to arrive on Earth, delayed by many hours. Each one carried information about particle energies, densities, and magnetic field directions. Scientists debated whether the spacecraft had truly crossed into interstellar space. The data was complex. Some indicators suggested it had. Others seemed to contradict that conclusion. This uncertainty lasted for months. Eventually the evidence accumulated. The particle environment had changed in a sustained way. Cosmic rays from outside the solar system dominated. Solar particles diminished. The magnetic field showed characteristics consistent with the interstellar medium. Voyager had crossed the Heliopause, yet even in that moment there was no visual confirmation. No photograph of a line drawn in space. Only numbers and patterns. The edge that isn't an edge became real through patience and interpretation. As you lie there now, letting this story unfold at a steady pace, consider how often we look for sharp boundaries in our own lives. Clear endings, definitive transitions. The universe rarely provides them. Voyager's journey shows us that departure can be gradual, that influence can fade rather than snap, that leaving one environment and entering another may take years, not moments. The heliosphere still surrounds the Sun. It still protects the inner planets from much of the galaxy's radiation. It still expands and contracts with solar cycles. But Voyager now resides in a region where the galaxy speaks more loudly than our star. This does not mean it is lost. It means it has entered a broader context. The solar system, once imagined as a compact arrangement of planets, now appears as a bubble within a vast sea. Its boundary is not a wall, but a negotiation between forces, and Voyager, by simply continuing forward, made that negotiation visible. The edge that isn't an edge is one of the most important lessons of this journey. It reminds us that scale is not only about distance, it is about gradients, about how influence weakens and strengthens over space. As Voyager continues deeper into interstellar territory, it carries with it the memory of the Sun's domain, and the evidence that boundaries in the cosmos are rarely as sharp as we once assumed. Long before any boundary could be named with confidence, before anyone could point to a graph and say, "This is where it happens," Voyager began to experience the first undeniable sign that the Sun's outward reach was no longer unchallenged. The change did not arrive with spectacle. It did not announce itself. Instead, it appeared as a quiet alteration in behaviour, subtle enough that only careful instruments and patient analysis could reveal what was going on. This moment is known as the crossing of the termination shock, and despite how dramatic the phrase sounds, it is not a collision in the way we instinctively imagine one. Nothing crashed. Nothing broke. Voyager did not strike a wall. What happened was far more restrained and far more instructive. To understand why the termination shock matters, it helps to think again about the solar wind. The Sun constantly releases a stream of charged particles, mostly protons and electrons, flowing outward in all directions. Near the Sun, this flow is energetic and fast, moving at hundreds of kilometers per second. It is this wind that inflates the heliosphere, carving out a cavity in the interstellar medium. For a long time, as Voyager travelled outward, that wind behaved predictably. It streamed past the spacecraft, its properties changing gradually with distance, but always maintaining its outward rush. The Sun was still firmly in charge, but the solar wind does not expand into a vacuum. Far beyond the planets, it begins to encounter resistance. The interstellar medium presses back, not with forceful impact, but with persistent presence. Particles from outside the solar system exert pressure of their own. Magnetic fields intersect and interact. Eventually, the outward flow of the solar wind can no longer maintain its speed. That slowing is the termination shock. A shock, in physics, does not have to be violent. It simply describes a situation where a flow changes speed abruptly. In this case, the solar wind transitions from supersonic speeds to subsonic ones. It goes from rushing freely to pushing through resistance. Voyager crossed this region not once, but twice, because the boundary itself moves. This is an important detail that often gets overlooked. The termination shock is not fixed in space. Its distance from the Sun changes as solar activity rises and falls. When the Sun is more active, the solar wind is stronger, and the shock is pushed farther out. When the Sun quiets down, the shock moves inward. As a result, Voyager encountered the termination shock during a period of changing solar conditions. The spacecraft crossed into the region, then later crossed back out as the boundary shifted, and then crossed it again. Each crossing provided valuable data. The instruments on board Voyager detected changes in particle speeds, densities, and energies. The once fast solar wind slowed noticeably, Its temperature increased as kinetic energy was converted into heat. Turbulence increased. This turbulence is another reason the termination shock does not feel like a clean edge. Instead of a smooth transition, the environment becomes messy. Particles scatter. Magnetic fields twist and fluctuate. Conditions vary from one moment to the next. From Earth, scientists watch these changes unfold with cautious excitement. This was not just another milestone. It was the first direct measurement of a region that had been theorized for decades but never observed directly. Until Voyager, everything we thought we knew about the termination shock came from models and indirect evidence. Now, for the first time, we had a probe moving through it, measuring it from the inside. What those measurements showed challenged simple expectations. The termination shock was not where some models predicted it would be. It was closer to the Sun than expected in some directions, farther in others. It was asymmetric, shaped by the local conditions of the interstellar medium and the orientation of magnetic fields. This asymmetry matters because it tells us that the solar system is not moving through space evenly. Our Sun is travelling through the galaxy, encountering regions of varying density and pressure. The heliosphere is shaped by that motion. In other words, the solar system has a kind of wind of its own, flowing around it as it moves through the Milky Way. Voyager's crossing of the termination shock revealed this interaction in real time. The data also showed that energetic particles behaved in unexpected ways. Some particles appeared to be reflected back toward the inner solar system. Others gained energy through complex interactions near the shock. This region turned out to be an important accelerator of particles, contributing to populations of energetic ions that had puzzled scientists for years. None of this was obvious at first glance. It took months and years of careful analysis to piece together what Voyager was telling us. Graphs were compared, models were revised, assumptions were questioned. All the while, Voyager kept moving. From the spacecraft's perspective, nothing special happened. It did not slow down. It did not change course. It simply passed through a region where the environment behaved differently. This is one of the most striking aspects of the termination shock. It exists entirely in the behaviour of invisible things. You could pass through it without ever knowing, unless you were equipped to measure the subtle details of particle motion and magnetic fields, and yet its significance is profound. The termination shock marks the beginning of the end of the Sun's unchecked influence. Beyond it, the solar wind no longer dominates. It still flows outward, but it is constrained, slowed, and reshaped. This is the first point where the Sun is forced to compromise. For listeners resting now, letting this idea settle without urgency, there is something quietly reassuring about that compromise. Even stars have limits. Even powerful, long-lived sources of energy must eventually negotiate with their surroundings. The Sun does not rule indefinitely. It participates. Voyager's crossing also underscored how large the solar system really is. The termination shock lies far beyond the orbit of Neptune. Crossing it required decades of travel at record-breaking speeds, and even then, crossing it did not mean leaving the solar system. This distinction is important. The termination shock is not the boundary of the heliosphere. It is the beginning of a buffer zone. Beyond it lies the heliosheath, a vast region where the slowed solar wind continues outward, interacting chaotically with the interstellar medium. Voyager would spend years in that region. So even after crossing the termination shock, the journey was far from over. The solar system still extended outward for a distance comparable to the entire planetary region many times over. This realization further dismantles the idea of neat boundaries. If the termination shock were the edge, the story would be simpler. But it is not. It is a threshold into complexity. Another subtle aspect of the termination shock involves time. Changes at the Sun take years to propagate outward to this region. When Voyager detected variations in the solar wind near the shock, those variations reflected solar conditions from long ago. This creates a layered timeline. Voyager was measuring the Sun's past while Earth was experiencing its present. The solar system, in a sense, contains multiple versions of the Sun at once spread across space. That idea alone reshapes how we think about distance. Space is not just separation, it is delay. It is history stretched thin. The termination shock is where that stretching becomes impossible to ignore. Engineers monitoring Voyager knew that power was slowly declining. Instruments had to be prioritized. Every measurement taken in this region was precious, because there would be no second chance. The spacecraft was doing something no other human-made object had done. It was measuring the environment at the far reaches of the sun's influence, directly and continuously. As Voyager crossed and recrossed the termination shock, the data accumulated into a picture that was richer and more complex than expected. The boundary was dynamic. The region was turbulent. The interaction between solar and interstellar forces was ongoing, not settled. This dynamism tells us something important about scale. Large structures are not static. They evolve, breathe, and respond to changes both internal and external. The solar system, often imagined as a clockwork mechanism, turns out to be more fluid at its edges. Voyager's experience at the termination shock forced scientists to abandon overly simple models. The heliosphere could not be described as a smooth bubble with a clear outline. It was irregular, responsive, and shaped by forces beyond our star. This realization feeds directly into a deeper understanding of what comes next. Beyond the termination shock lies a region where the sun's influence continues to weaken, where the solar wind is slowed and heated, and where interstellar particles increasingly assert themselves. The termination shock is the first step into that region, a warning sign, not an exit sign. For those listening now, allowing this story to move at an unhurried pace, it may help to think of the termination shock not as a dramatic crossing, but as a change in tone. The music of the environment shifts, the dominant instrument softens, others begin to be heard. Voyager listened to that shift with its sensors, translating invisible interactions into numbers we could study. As the spacecraft continued onward, the solar wind behind it still flowed, still carried the sun's signature. Ahead of it lay a region where that signature would become increasingly faint. Crossing the termination shock was not the end of anything. It was the beginning of a longer, quieter passage through a place where the sun no longer spoke with a single, confident voice. Between the certainty of the sun's inner reach and the vast openness of interstellar space lies a region that does not announce itself loudly, yet quietly reshapes everything that passes through it. This is the heliosheath, and entering it marked a profound change in Voyager's environment. Not because something suddenly happened, but because everything began to behave differently. After crossing the termination shock, Voyager did not arrive anywhere recognizable. There was no sense of completion, no feeling of having reached a destination. Instead, the spacecraft drifted into a zone where the rules softened, where the solar wind no longer surged confidently outward, and where the influence of the galaxy began to press in with patience rather than force. The heliosheath exists because the solar wind does not simply stop when it slows down. Once it passes through the termination shock, it continues outward, but now at reduced speed and increased temperature. The particles become more chaotic, their paths tangle, the once smooth flow turns restless and uneven. This region is vast, larger than the entire planetary system many times over. Voyager would spend years crossing it, and during that time the spacecraft provided the first direct measurements of a place scientists had only imagined before. From a distance, the heliosheath might sound like a boundary layer, a thin skin between two environments. In reality, it is more like a wide, unsettled frontier. The solar wind, weakened but persistent, pushes outward. The interstellar medium pushes inward. Neither fully dominates. As Voyager entered this region, its instruments detected an increase in turbulence. Particle densities fluctuated. Magnetic fields twisted and shifted orientation. Conditions changed over time, responding both to solar cycles and to the surrounding galactic environment. This turbulence is not violent. There are no explosions, no sudden disruptions. Instead, it is slow and complex, like currents mixing in deep water. Motion exists, but it is subtle. Energy is redistributed rather than released. The heliosheath challenges our instinct to think of space as static. Even far from planets, even beyond the sun's confident reach, space is active. It is shaped by competing pressures and long-term interactions. One of the most striking features Voyager detected in the heliosheath was the changing balance of particles. Solar origin particles, once dominant, became less prevalent. Interstellar particles grew more common. Galactic cosmic rays, high-energy particles born from distant supernovae and other energetic events, penetrated deeper into the region. This shift did not happen overnight. It unfolded gradually, reinforcing the idea that the solar system fades rather than ends. For scientists on Earth, interpreting this data required patience. The heliosheath did not behave uniformly. Measurements varied depending on direction, time, and solar activity.